Let's run through another Mtel question. This one says, use the diagram below to answer the question that follows. It says the signal from cell tower T extends over a circular area for a radius of 50 miles, with highway AB passing through the service area as shown. If angle ATB is 140, which of the following expressions represents the length in miles of highway AB within the service area? And we've got a bunch of answers that have trig functions in them. Sine and cosine are really only useful for 90-degree triangles. There are some circumstances where they're used otherwise, but we don't have a 90-degree triangle here, which is going to make this kind of tough. Sometimes you use law of sines and law of cosines, but you need more information about the triangle to be able to do that. It would be nice if we had 90-degree triangles here. And there's a rule that we can use with circles where if a chord passes through the edges of a circle, you can draw a line from the center to the chord, and if you bisect that chord, it's going to be the perpendicular bisector. Pretty tricky rule, but I'm going to draw a line from the center of the circle down to this line. So I'm going to say that I can definitely prove that this line is making 90-degree angles with this and cutting this line in half. And that's useful because now we have two separate 90-degree triangles that have a hypotenuse of 50 miles. So one of the crucial elements of trigonometry is understanding Sohcahtoa. Hopefully you've seen this before at some point during your math career. Sohcahtoa just means that the sine of an angle equals the opposite over the hypotenuse. Cosine equals the adjacent over the hypotenuse. Tangent equals the opposite over the adjacent. So in order to solve these triangles, if we have a side length as well as an angle measure, we should be able to use Sohcahtoa to solve the triangle. Well, this whole angle, this big angle in the center of the circle was 140. So this angle in the smaller triangle that I've created and this angle, both of these angles right here, are 70 degrees because that's 140 divided by 2. Because there's two angles. This angle is bisected by this little line that I drew. So now I know that I have a 70-degree angle in this triangle with a 50-mile hypotenuse. So what else are we wondering about in this diagram? Well, I want to know the distance from A to B, and I know that both of these little segments are half of that length because this little piece bisected it. So if I can find this side length right here, I should be able to double that and find AB. Well, in terms of the angle that we have, we know that this angle right here, is 70. And this side is opposite that. That's going to be our O. Our O side is opposite the 70-degree angle. And this side is opposite the right angle. So that is our hypotenuse. So that's our H. So we've got an O and an H, which looks like the SO part of this to me. So I want to use sine to set up our equation. So again, SO means sine of the angle, which is 70 degrees, equals opposite over hypotenuse. We don't know the opposite, so it's going to be O divided by our H, which is 50. If we solve for O in this equation, we're just going to multiply by 50 on both sides, so that's 50 sine 70 equals opposite. But we're not just looking for the opposite. We know we have to multiply this times 2 to get all of AB. So if we multiply 50 sine 70 times 2, we get 100 sine 70, which is answer B.